Okay, hi everybody. What I'd like to do actually right now is work through this data set with you here kind of together. Look at this Proto-Bantu data set, and I'll just give you a sense of what it is that I'm looking for and how you might go about actually solving this problem. So to start with, what we're going to do is, first off, the very first step that you always want to do is check for minimal pairs. In this case, actually, we don't need to, because it says right up at the top here in this data set that you are unable to find minimal pairs, that it is complementary distribution. So we know that already. That's not a problem. Why is this not working? There we go. We see complementary distribution right here. So we know that's not a concern. Next, what I want to do is start looking at the environments here. And so what I might do is I'll zoom in a little bit. And what we're after here are the beta versus B, the L versus D, and the gamma versus G. All three or all of those things are in complementary distribution. We know that already. And so the question is, what is the relationship between the betas and the Bs? What is the relationship between the Ls and the Ds? What is the relationship between the gammas and the Gs? So what we're going to want to start doing here is to look at each one of these things and get a sense of what their environments are like. So let's start off actually by doing some, we'll start off with the betas. So the beta here occurs in what context? So here in the very first item that we see here, we see that it happens between a word boundary and the ah. Okay, great. The second one we see happens between an I'll just draw them like that, make it easier, an and an a. And the reason I say that is that in this data set, we don't have any contrast between these two things. Anyways, there we go. So we've got and I'll draw it this way to be a little bit more consistent, and Next thing we have a beta is between start of the word and an looks like, down here in number 7. In number 8, we have, again, start of the word, and we have another Okay, where's my next beta? The next one is number 20, which is the start of the word and the vowel. Okay, and are there any other betas? No, so we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, and 5 betas. Okay, great. So that gives me the distribution for beta. We know exactly what's going on inside this beta, and I'll just clean that up a little bit. So that way we can, now let's compare it to its friend. Let's compare it to the B sound that we see. So let's take a look here. The very first B that we see is in Bembe. Okay, so we see that that comes between an M and an E. So right here we have an M and we have an E, so we can draw it out like that. The next B we see is in 11, so we have an M and an E. Okay, good. There are no others in the first column. Okay, let's look at the next column. Let's go through, and there are no other B's there. Okay, interesting. So we have all of these guys, and we see that beta and B, there are some signs here. I mean, already looking at this, there are a couple of things that we can notice. We can see that all of the betas are followed by a vowel, but actually, so are all of the B's. So this isn't actually helpful to us. That's not a generalization we can use. Next, we see that a lot of the betas come at the start of a word, but not all of them, because this one here doesn't. And again, that makes it problematic because, well, okay, this is either before a vowel or at the start of a word. That's not a great law here. One thing that is kind of promising is in the B's, we see both of those occurring before an M. Nice. Okay, so that's useful. This is good information. Let's go ahead and move on to the next word that we want to look at, the next sound. And this is a more complex data set than I'm usually going to give you, but it's still useful for you to get a sense of it. Let's look at, and I'll try and do it a little bit smaller here. Let's look at L first. So I'll just go ahead and I'll write an L right here. And I'll try and do it a little smaller. So here we have start of the word A in this particular case. Next we have and in this case. We have start of the word and E in this case. Next we have 2 L's in that word. So we would do one is start of the word followed by an L. The other one is an A, or I'm sorry, not followed by an L, followed by an A. Next one is that A followed by an open O, an O. Let's look for, okay, we have in this one here, and I'll mark, yep, we have that one between an oo and an oo. Okay, we have this one between an ah and an ah, which is the same thing we have here above, but no big deal, right? That works. Then we have an ele in this case here, and we have an u. So we have, for this one, start of the word and then or I'm sorry, that was an not an a. Let me fix that real quick. An and then here we have an followed by an oo. Okay, good. And that's all the L's. We've done all of the L's in this data set here. Great. So now, right here, looking at this, no clear super patterns. I mean, they're all followed by a vowel. That's useful. But again, we saw that above here too. Let's look at the D instead. So I'll switch to green for the D. Enjoy the clashing colors. So we have a D here in this word. So that comes between an N and an E. Great. Okay, we see another D in the, and some of you may have figured this out already, but that's okay. Where's the next D here? We've got that one. Okay, here's one, intende. So we have an N followed by an E. And that's it. There are only 2 Ds in this data set. All right, cool. Now, finally, let's look at the last pair that we've got here, which is the gamma and the G. So we'll put the gammas down here. Let's do gamma, the aga sound. So where's that? We have, oh, right here, there's no gamma, no gamma, gamma. Okay, and that's between an and an a. Here we have one at the start of a word next to an o. Here is an, well, up here actually. So I've got that one. Where the heck was that? Oh yeah, I checked that one off. Great. So here's an E next to an A. So E, A. Great. Here's a pair of gammas. So in we have one is between the start of the word and an E. The next one is between an E and an A. Great. And then here's one between an open O and an oo. So we've got that one. We've got this one. Sorry, this is, there we go. And, oh, this one here. So an A, between an A and an E. Okay, so that's all of our gammas here. Looking at the pattern here again, we have vowels and start of the words, and then vowels on the other side. And then finally, let's go ahead and do the G pair. So G, we don't have, oh, here we go. We've got a Ng followed by a G. That's no shock, because velar like velar, nasals like to assimilate. That's how they be. And a Ng followed by a G followed by an A. Okay, so we got that one too. Got that. Here we have a Ng followed by an O. Ng, O. And then, great, we have a Ng followed by an open O. All right, so at this point in time, you're probably starting to pick up on what's going on. If we look at all of these fricatives, so, and they're not actually fricatives, so the beta here is a fricative, the gamma here is a fricative, the L is an approximant, but these are all sounds that have air flowing continuously, right? Call them continuum, whatever you'd like. Although, anyways, that's a 111 issue. But we have stops here, b, g, and duh, and then we have the other things. If we look at the other things, if we look at the fricatives and approximants, we see no clear pattern. We see here vowels and start of the word, all vowels. The thing is, here we have all vowels, so that doesn't work. It can't be following vowels. Again, vowels and start of the word, all vowels. Vowels and start of the word, all vowels. That's not winning us much. It's hard to predict what's going on from the betas, the gamma, and from the L. What we can look at is the other side. We can look at the stops. And if we look at the stops, what we see here is a very striking pattern. Every one of these is a ng, right? Every one of these has an m, and every one of these has an n. So not only do we see here that all of the stops are preceded by a nasal, but that nasal is at the same place of articulation, actually. What I mean by that is that this is a B and it's before an M, or I'm sorry, it's following an M. So it's homorganic. It's the same place of articulation. Same thing with D and N, G and N. So, okay, this gives us a theory, right? It gives us an idea. We can say, okay, every nasal, or I'm sorry, all of the stops come after nasals. So what we do is we'd want to go back and check our theory. We'd want to make sure that none of the fricatives have nasals, and indeed, none of the fricatives have nasals. That's easy enough. We'd want to look in the data set to make sure there are no nasals that don't have, that are followed by the gammas. We've got that already. We'd want to make sure that there are no other cases, for instance, where there's not a nasal in front of these guys. No, that's confirmed. So we can make our theory here. It looks like the stops become, the fricatives become stops, or the continuants become stops after a nasal. So, okay, which is our underlying form here? Now we ask ourselves, what's easier? It's kind of hard to describe the distribution of the continuants, right? That's ugly. I don't want to do that, because I'd have to say something like start of the word, or a vowel, before a vowel, etc. No. Don't fight that. So instead, what we'd want to do is just take as our rule, we would want to say something like, let's pick a color here. We would say that the underlying form here is the beta, and then we would make a rule. So we'd put that as the underlying form. We'd make a rule that says beta goes to B. So that's our underlying form, and we would do the exact same thing for the other fricatives. So we'd say gamma here goes to G, and then we would say the L, which is weird between slashes, becomes a D. Easy. Now we just need that environment. So looks like they're all happening after nasals. So we would say beta goes to B before nasal. So we could say this goes on before an M. So actually, there are two ways we could write this rule. We could do one of them with M, and then we would have to do this one with ng, and then this one with, not with D. That's exactly what I'm talking about. With N. So we could write it that way. Or we could actually generalize. We could just say before a nasal, etc. That's fine. Could work. Can we predict which one of these is going to show up at any given moment? No, we can't. We can't, for instance, say some underlying form is shared between all three of these. That wouldn't work. We can't have one rule that will do all three of these things and tell us where the betas should be, etc. But what we can do is a rule that will say something that combines all of these, because all of these rules are doing effectively the same thing. So we could say something like, we could do either a joint rule. So we could say something like, beta, gamma, and L, it's supposed to be a bracket, become, and in this case I'm showing it in brackets because it's a list, B, G, D, in the environment after a nasal. And that's a rule that would give us all three of these things. You could also do something a little bit fancier and say something like continuance. By the way, pardon my handwriting. I was raised by two doctors, doomed from the start. Continuance, go to stops. In the, and actually we'd have to do voiced, become voice stops, following a nasal. And by the way, you can just write an uppercase N to mean any nasal. So I'm just going to go ahead and do that here to simplify things. So then the simplest version of this rule would be this. Any voiced continuant in this language becomes a voice stop following a nasal. And actually that last little underline is ambiguous, right? So this is how you would solve this problem. You don't need to look for minimal pairs here because that's not the way this data set needs to work. You'd find the distributions. You'd look at the distributions for patterns. You'd try and find an underlying form, and then you would write some rules. And I would accept for 101 this set of rules, or you could combine them, or you could write one rule that works for all of them. Either way, it works, and that's how we would go ahead and do this data set. This data set is actually a little bit more complicated than the ones I'm going to be giving you in homeworks and things like that, but it gives you a sense of one with a bunch of moving parts and shows you the process in a couple of different times. So I hope this was helpful for you, and have a wonderful rest of your day.